Hi, today we are going to look at rank correlation coefficient. Rank correlation coefficient, this is a method which quantifies the degree of relationship between two variables by ranking them. So one way of getting rank correlation coefficient here in the correlations, we are going to use Spearman'S correlation. Now, under Spearman'S correlation coefficient, the variables are ranked according to the level of importance or magnitude of the scores. And Spearman'S rank correlation coefficient is calculated from, here there is rank, from rho, which is equal to 1 minus. So Spearman'S rank correlation coefficient, rho is calculated from the formula 1 minus 6 summation d squared all over n into n squared minus 1, where d is the difference between the ranks, n is the number of pairs. So here we are going to look at a bivariate distribution. We have to make some notes. Rho is the value which lies between -1 and +1. So when rho is equal to -1, like we saw from our graphs in the previous lesson, it was actually the first lesson, we saw some types of correlations there. We saw perfect positive, we saw perfect negative, we just saw positive, we saw zero correlation, we saw negative correlation. Now here under rank correlation coefficient, here we are quantifying our relationship. In the previous lesson, we were not quantifying, we were just looking at the behavior of the graph, and then we make a conclusion about the correlation. So here we are going to quantify our relationship, and the value which is used to quantify the relationship, which we call the Spearman'S correlation coefficient, is a value that lies between -1 and +1. So when you calculate and you find that the rho is equal to -1, this means a perfect negative correlation. When the rho is equal to +1, you calculate and you find that rho is +1, this is a perfect positive correlation. Okay. How about if you calculate and you find that rho is equal to 0? This will be 0. We saw that type of correlation, 0 correlation. Then other values which lie in the ranges of -1. So the values which lie in the ranges of -1 and 0, then 0 and +1 are going to be determined using the table of magnitude, which we are going to draw here. So we have talked about when rho is -1, or when we calculate and we find that our correlation coefficient is -1, we make a conclusion and say this is a perfect negative correlation. If our rank correlation coefficient is +1, we make a conclusion and we say this is a perfect positive correlation. If rho is equal to 0, this means that there is no correlation. But remember, we said that rho is a value. It can be any value that lies between this range here, +1 and -1 inclusive. Okay. So this simply means that if we have talked about those three cases, those three special cases, Then we can as well talk about the values which lie in between here, okay? And these values are going to be summarized in the table below with their interpretation according to the ranges, So the table which you are going to draw here is going to be a table which shows the magnitudes of those values. The magnitudes of those values is what you are going to draw next. So within this table, we are going to fill in the ranges, and here we have our calculated value of rho. So, and here we have the interpretation. Then when we calculate the correlation coefficient, and we find that the value is ranging between 0.00 to 0.19. What is the interpretation? This shows that we have very low correlation. Next one is 0.20 to 0.39. This shows low correlation. And the other one picks on from 0.40 to 0.59, showing moderate stroke substantial. Then another range picks on from 0.60 to 0.79. This shows a high correlation. And the other one picks on from 0.80 to 1.00. Remember, we said that the magnitude, if we have to take the magnitude of this, you realize that the maximum value is 1, the magnitude. So this shows very high correlation. Now, we have been up here. Here we interpreted special cases. Those are 3 special cases which we have interpreted so far. How about if we calculate our value and we find e.g., we need to make a comment on the following values of rho. Roman numeral 1, when the rho is equal to 0.81, what will our comment be like? Just like the way we made the comment up here, these ones, their comments were automatic. But when it comes to these other values which lie between 0 and 1 for this case, we have to use our table. 0.81 is a value that lies in this range here. It's a value that lies in that range, this range here. So the interpretation is going to be, first of all, the sign is also very important, because we have said that we have now 2 ranges. We have the negative range, that's from -1 to 0. Okay, they are not excluded at this time. Then we have a positive range from 0 to 1. These 2 ranges. So we have to comment basing while checking on the what? While checking on the sign which our value is having. So for this case, it is a positive one. So our comment is going to be very high. Then the sign of our value comes in, very high positive correlation. Okay. So number 2, how about if they gave us rho being equal to -0.42? What would be our comment? Still, we come to our table, we identify the magnitude of 0.42. This table here shows the magnitude of the value you get. So, what's the magnitude of negative 0.42? Someone is going to say 0.42 it's going to be a positive value. So, what are we going to make as a comment? So, 0.42, when it comes to this table, is a value that lies in here. 0.42 lies in here, in this range here. Okay, so what should be our comment? Let's write this is a moderate. This is a moderate. Now we look at the sign, just like the way you saw here. Up here we say very high, then the sign of our value came in. So this is moderate negative correlation. Okay. How about if we have rho as being equal to negative 0.9? What would be the answer? Yes. What would be the answer? Someone there would say the magnitude of negative 0.9 is positive 0.9, the magnitude. And this table shows the magnitudes. So we go to our table here. 0.9 is a value that lies here. 0.9 is a value that lies in this range. So what would be the comment? The comment would be very high. The sign follows negative correlation. So we have seen the theory behind. Correlation. Next, we are going to look at an example. Now, what we have to know, and which is very key, is how to rank our values. We said that we are going to rank our values. Let me go back up here a bit. When we are using Spearman's rank correlation coefficient, the variables are ranked. The variables are ranked. Yeah. According to the level of importance or magnitude of the scores. That is very important when it comes to ranking our values. Let's have an example. The data below shows the scores of 8 students in subject X and Y. So this is our table here. They're asking us to calculate the rank correlation coefficient between the two subjects X and Y. Then after, we shall have to make a comment basing on the value which we have got. So let us start. The first step is to rank. And before we rank, we have to take positions first. So if these are our values, the color. So these are our values. We have to rank at these values according to the level of importance. Since these were marks, the higher mark is important. So it takes rank 1. So let's start ranking. The highest mark is very important and it takes our rank 1. Okay. So for X, this is taking rank number 1 or position 1, followed by 76, number 2, followed by 72, here number 3, followed by, this is 64, number 4, 68, number 4 here, then number 5 is here. Okay, number 6 is this 60 here. You look at these ones. Number 7 is 56. And then when you scan through, 52 becomes number 8, the last one in our rank. So we are ranking them according to their level of magnitude. The bigger one having rank number 1. In other words, it is the most important. So next we are going to rank those in Y. Those in Y. Those in Y. 74 is the biggest one, so it takes our rank 1. Followed by 68, rank number 2. Followed by 66, rank number 3. Followed by 60, rank number 4. Followed by 56, rank number 5. Followed by 52, number 6. Here, rank number 7. In this case, position is the same as ranking. But as we move on, we shall see that ranking is different from positions actually. Now, for us, just know that we are going to be dealing with the ranking. Okay? Just know that we are going to deal with ranking. So, we have position, and because there is no any other value which is repeating here, this one's qualified directly to be ranks. Just be patient. Just be patient. You're going to understand what it means to position and to rank. So what you have done here is ranking and at the same time positioning. These are positions and at the same time ranks. Okay, stay with me. We are going to have the next number, which is going to bring in the distinction between the ranking and the position. Let us deal with this one in this video. Thank you. Now let's go ahead and rank them. From here, please note this table down as we move down. So I'm going to have a rank of X. Then I have D, because we say that D is the difference in the ranks. Then we shall have D squared, because according to the formula, rho is equal to 1 minus 6 summation D squared all over N into bracket N squared minus 1. So we need to, N is the number, pairs, D is the difference between ranks. Okay, so have our table. So we are going to fill in that table. We have the rank of the X, we have the rank of Y, and this D is the difference in the ranks. Then we shall have to go ahead and square the D. Now these are the ranks which I'm just going to carry these ones and I place them here. So I'm going to start with the rank for X. Have the first value, we'll have rank 6, 3, 7, 2, 4, 8, 5, 1, like that. So I have those values there. Then we have 6, have 3, 7, 2, 5, 1. Then second row, second column here, shall have the ranks for Y, which are here in red. This one's in red. That the ranks for Y. So we are going to start with 7, 5, 4, 1, and so on. So let's have them there. Alright, now those are the ranks. We have finished the ranking, the two variables, X and Y. Next, we need to get the difference between the ranks. We need to get the difference between the ranks. So we are going to have D as being equal to Rx minus Ry. Let's subtract 6 minus 7, negative 1, 3 minus 5, negative 2, 7 minus 4, this is 3, this is negative 1. Next, we are going to square D. This is now D, we are going to square it. So 1 squared, negative 1 squared, 1, yeah, 4, yeah, 3 squared, you get 9. 1 squared, you get 1, 1 squared, you get 1, 1, and you square it. So next we need to get summation, D squared we are going to add, when you add this all, you get summation b squared. Summation b squared is 18. Okay, so now we are going to calculate. Therefore, we need the rho. Rho is equal to, by formula, 1 minus 6 summation b squared divided by n into bracket n squared minus 1. Okay, so what is our n? N is equal to 8. Summation b squared is equal to 80. So let's substitute. Rho is going to be 1 minus 6. Summation b squared is 18. This here. Summation b squared is actually 18 divided by, this is 8 into bracket 8 squared minus 1. When you happen to get your calculator, this is 1 minus 108 divided by, when you square, this is multiply here, you have to get 504. So when you divide and subtract there, rho is going to be equal to, in my calculator, is 0.7857. Okay, for now, according to our question up here, we are done with calculating the rank correlation coefficient in our table here. We say that if the value is not -1, it's not 0, it's not +1, then this table here can be very important for us. Okay, so now let us look at the value which we have got. We have got 0.7857. 0.7857 is a value that lies within this. So what should be our comment? Because Roman numeral 2 is requiring us to comment. What should be our comment? We write high. Okay, so our comment, rho is equal to 0.7857, shows a high positive correlation between x and y. We are done with the commenting. Thank you very much. We shall not just go home like that, or an exercise for you. Let's try out this one. So here is our number which you're supposed to try. The table below shows marks obtained by 7 students in math, physics, and biology. Math, they are here. All these are math marks. All these are physics, biology. The question requires us to calculate the rank correlation coefficient between the performance of students in Roman numeral 1, math, and physics. So you're going to base on this table. Math and physics is here. So you're going to first take math and physics. You calculate for the rank correlation coefficient like the way we have been doing it. Okay, after you have got that value, keep it. Go to Roman numeral 2. They want us to calculate the rank correlation coefficient of the students in math and biology. So math is here, biology is here. Okay, so we need to calculate the rank correlation coefficient for the two subjects, math and biology also. Then we are tasked to comment on the relationship between the performance in this Roman numeral 1 and Roman numeral 2. So this question basically has two questions indirectly which are embedded together. So it is going to give you a good experience, I know, to interact with it now that we know how to calculate and comment on our value. Now, what we have been dealing with, we have been seeing that the rank is the same as the position. Now, in the next video, which you're going to have, we are going to have an example whereby the rank is not going to be the same as position. We are going to realize that they are actually different basing on the behavior of the values which will be given here. So stay with me not to get out of track. We shall reach there. So see you in the next video. Please make sure that before leaving, subscribe with us, and we shall be unveiling videos of this kind and more others which will be coming our way. Thank you very much.